Quadratic inequalities, make some notes, and we move forward. Right then, in order to be able to solve quadratic inequalities, we're going to do three things. First, we solve the quadratic equation, and we generate what's known as the critical values. And we sketch a graph of the equation, and then third and final point, we decide on the range of values that we're going to take. Okay, so let's have a look at the first question. Example: find the set of values for which the quadratic x squared minus 4x minus 5 is less than 0. So write that example down and we'll attempt to solve it. So we solve this as a normal quadratic. So we take our x squared minus 4x minus 5, and we say it's equal to 0, and we solve it as a regular quadratic. So I've got x and another x here equals 0. I've got a minus 5 here. I'm looking for factors of 5. It's negative 5, so one of these has got to be negative. It's negative 4x, so it's going to be minus 5 and plus 1. So x minus 5, x add 1. Which means that either x is equal to 5 or x is equal to minus 1. Now these are known as the critical values. We've solved the equation, we've got our critical values. Now we need to sketch the graph of the equation. Now then, my y-axis, my x. I know it passes through 5, oops, that's a minus 1 there, and minus 1. So, and I also know that x squared minus 4x minus 5 is a happy quadratic. So I'm going to sketch it, smiling. And it's passed through minus 1, and it's passed through 5. Now to solve it, it says it wants the range of values for the quadratic x squared minus 4x minus 5 less than 0. So our x, where are x values here, where does it fall below the graph? So it's going to start from here, oops, to here. And that's the range of values for which it's less than 0. Okay, so that means that the x values are going to be less than 5 but greater than minus 1, and that's the range of values that solves that quadratic. So anything from minus 1 to 5 is below. Everything else, my curve, as you can see, has positive y values, so we can't take those. We only want these ones that range from here to here. Good. So I want you to make some notes. Sketch the curve. You have to sketch a curve. You have to sketch a curve every single time for these kind of equations. Otherwise you can't solve it. You can't determine whether it's above or below the x-axis. Okay. So hit pause, make some notes. When you're ready to move on, hit play again. Second example. Find the set of values, or the range of values for x for which 3 minus 5x minus 2x squared is less than 0 again. So less than 0. But if I note this time, I have got a negative quadratic. So I take that and I set that equal to 0 because I want to solve it first, which means finding my critical values. So I've got 3. Whoops. I've got 3 minus 5x minus 2x squared equals 0. Now if I times each term by minus 1, I get minus 3 plus 5x plus 2x squared equals 0, and rearranging that I end up with 2x squared plus 5x minus 3 equals 0. Now I need to solve that in terms of find what my x value is. Now it's going to be 2x times x. So if I have 2 and it's got factors of 1 and 2, and I've got minus 3. Minus 3 has factors of 3 and 1. Hopefully I've written them in the right place. 3 times 2 gives me 6, 1 times 1 gives me 1. So 6 take away 1 will give me my 5 in the middle. But I know one of these has got to be negative. Okay, it's got to be the negative 1, because 3 times 2 gives me positive 6. So 6 take away 1 will give me my plus 5x there. So the 2 has got to multiply the 3. So the 2x has got to multiply the 3, which I put here. And the 1 multiplies the minus 1. So that implies then, this is a sign for implies, that either 2x is equal to 1, which means that x is equal to a half, or x is equal to minus 3. So again, we sketch the curve. So those are our critical values. And we sketch the curve again. I know it passes through minus 3.5. I also know it's a negative quadratic. So a negative quadratic means that it's a sad quadratic passing through, so extend that a bit, passing through minus 3.5 there. So that's my half, and that's my minus 3. My y-axis and my x. And I want to find the values for which this function is less than 0. So less than 0 again is going to be here. So wherever the equation takes the values of a half or more, so it's going to go outwards, or minus 3 or more, it's going to fall below 0. So we can say that our solution then is x is going to be less than minus 3, or x is greater than a half. And that's our solution for this quadratic. Now you have to sketch it to see it. You have to sketch the curve to see the values of y. This is our graph. Oops, curve goes that way. F of x equals 3 minus 5x minus 2x squared. So that's our curve, and these values here are below the curve. So whenever x is bigger than a half, it's going to be below the x-axis, or it's less than minus 3. Good. Make some notes, sketch the curve, compulsory, and we'll have a look at another example. So our third example then, it says find the values of k for which the equation k plus 3x squared plus 6x plus k minus 5 is equal to 0 has 2 real roots. So it's got to have 2 real roots. Now, in order to have 2 real roots, the discriminant must be correct. Discriminant must be greater than 0. Now our discriminant, if you recall, is b squared minus 4ac, and it's got to be greater than 0 for it to have 2 real roots. So in this case, a is equal to k at 3, b is equal to 6, and c is equal to k minus 5. So we plug them into the b squared minus 4ac greater than 0, and we solve it to find a range of values for which k solves the equation. So if we do it over here, my b squared minus 4ac is greater than 0. So b is 6, so 6 squared minus 4 times k plus 3 times k minus 5. is greater than 0. So I've got 36 minus 4 into k squared. I've got minus 5 plus 3, so minus 2k minus 15 is greater than 0. Expand and simplify. 4 times 15 is 60. It's greater than 0. So I've got minus 4k squared plus 8k. And I got 60 plus 36, which gives me plus 96. Is greater than 0. So I've got to solve this then to find the values of k for which this works. This is greater than 0. First things first, I'm going to divide each term. I can see that 4 goes into all 3 terms. So I'm going to divide each term by minus 4. Now because I'm dividing by a negative number, the sign changes as well. So that gives me k squared minus 2k minus 4 into 96, 24 times, all right, 24. And instead of greater than 0, that's going to be less than 0. So now I can solve this. It's k, and I need the factors of minus 24. That will give me 2k. So how about 6 and 4 possibly? They should work. One's got to be negative, minus 2k, so it's going to be minus 6. So k minus 6, k plus 4. Oops, got my k there. Okay. So those are critical values. What have we got? Critical values. K is going to be equal to 6, or k is equal to minus 4. So this equation here is the one we're trying to solve for, where we're trying to find out where it's less than 0. So we sketch that curve. It's quadratic, it's k squared, so it's a happy quadratic. So if we sketch that, we'll have, remember it passes through 6 and minus 4, so sketching it like that. There we go. That's x and y, and that's our minus 4 and our plus 6. So which part of it is this equation less than 0? From here to here, because all of this region here is less than 0. So we can say that k is going to range, it's going to be less than 6, but it's also going to be bigger than minus 4. So those are the range of values. Let's solve for k. So what I want you to do is to hit pause, make some notes, and when you're ready to look at the last example, hit play again. Very good. Right then, this time it says find the set of values, or the range of values, for which 6 over x is greater than 2. X cannot be equal to 0, okay? Because if x is equal to 0, you get 6 divided by 0, which we can't do, okay? So what we do is we take our 6 over x, which is greater than 2, and we multiply by x squared. So we multiply both sides by x squared. So you got 6 over x times x squared, and that's greater than 2x squared. Now one of the x's cancels with one of those, so you got 6x is going to be greater than 2x squared. So 0 is going to be greater than 2x squared minus 6x, or if we write it on the other side, 2x squared minus 6x is less than 0. So we've got to solve that. Let's write it here. 2x squared minus 6x is less than 0. Factorize first. We factorize what's common to both. 2x, and we're left then with x minus 3 is less than 0. So either the critical values, either 2x equals 0, which means that x is equal to 0, or x minus 3 is equal to 0, which means that x is equal to 3. So those are our two values. It's happy quadratic. If we sketch it again, whoops, didn't turn out very well, but that's okay. Passes through 0 and 3, so I'm going to try my hardest to make sure it goes through. Oh, not too bad. It's my happy quadratic. Y equals 2x squared minus 6x, and we're looking for the part of it. That's y. It's not the best graph, but it'll do. It's only a sketch. So we're looking for the part of this curve that lies below 0, and that's this region here. That's our 0 and that's our 3. So the region where it lies below 0 is from 0 to 3. So we can say 0, x is greater than 0, but x is less than 3. Good. Hit pause, make some notes, and it's your turn to do some questions. Right. So I want you to complete exercise 3E for me. Not all the questions. If we were in class, I'd say work down the left-hand side of the page, but since we're not, and I know you're keen to attempt all the questions, I'm happy with you to do that. And it goes on to question 9. So enjoy.